Okay, Assalamualaikum. My name is Mohamad Zakir HAKIMIIE. My contact number is CE230067. For we are from section 2. So our data project is Eddy Induction Brake System. Okay, for the introduction, okay, for the project overview, a demonstration of time varying magnetic field and electromagnetic induction principle. For core mechanism is the interaction between a moving matter and magnetic field to create vacuum force without visual contact. For the power of induction, show how kinetic energy is transformed into heat through electromagnetic force.
Hi and a very good day, Dr. Yee. My name is MOHAMAD AMIRUL HAZIQ bin SUDERMAN, and my matrix card number is CE230079. And for today's presentation, I would like to elaborate more about the project, which is I will cover in two parts, which is the problem statement, and also the other one is the project objectives. So right now, I would like to explain about the problem statement. So in our world, the most braking system that is being used in machines and vehicles is relying on friction between moving parts to stop the motion. But with this traditional method, this method produces very much heat, noise, and also wear, where it is leading to the frequent maintenance, and it is reducing the efficiency over time. And for in the industrial use, the issue can also affect the reliability and the safety of the system itself. And then the primary issue with the traditional braking is the inevitable degradation and material, because as we know, when the two substances of traditional braking is making contact with each other, the brake pad or anything that is being used in the brake will be thinner and thinner, and as the brake pads and the rotors were being interacting each other, the layer of the material is being sheared off, leading to a gradual loss of braking effectiveness. And in a high output and in the industrial environment, this way necessitates the frequent downtime for inspection and the part elements. That means that if the regular maintenance is being held on and on each and every time of short period of time, it will increase the costing for maintaining the system itself. Next, I would like to give what are the objectives of us doing this project, which is the eddy current braking system. So the first one is we would like to demonstrate how by changing the magnetic fields, it induced eddy currents in a conductor. And then the second one is we are going to show on how eddy currents create a magnetic field that opposes the motion and producing the braking itself. And last one, we also would like to relate what are the braking effects to the real industrial application, such as the eddy current is being used in the trains, elevators, and machines. And one fun fact also, the eddy current braking system is also being used in the roller coaster, like the amusement park roller coaster. So it is widely used throughout our world. And in this project, we would like to show you all those applications of the eddy current braking system. Thank you.
Hello doctor, my name is NAJMI. My matrix number is CE230075. For scope of work, we have 3 main points. For first point is engineering and assembly. We build a small-scale functional prototype model. The selection of material demonstrating electromagnetic induction. Then for primary drive, we using DC motor and conductor circular aluminum disc. For second is theoretical validation. We proof of Faraday's law and Lenz's law. A demonstration of induced eddy current. Then the validation of secondary magnetic field and braking effect. For the last is analysis and application. We analyze of kinetic to thermal energy conversion, then is industry justification, such as high-speed rail and roller coaster. That's all from me. Thank you.
Now for the methodology. Before that, I introduce myself. My name is Muhammad AZIZI bin Muhammad Amirul CE 240065. For methodology, this slide project overview. So our project is an eddy current induction braking system. It is a non-contact braking method based on electromagnetic induction. When a conductive disc rotates in a magnetic field, eddy currents are induced, produce a braking force according to Lenz's law. So we use on this picture we use a disc wrapped with aluminum foil as a rotation conductor. So for this slide is the prototype and component. As you can see on this figure, there's a form based on our prototype. So the CD wrapped with the aluminum foil, it attached to a 3-volt DC motor. So the Young clamper magnet we stick for NAJMI magnet mount on a U-shaped holder made from the ice cream we crack it. So the magnet will place close to the disc without contact. So the system is powered by using two AA battery, and also controlled by the switch. And the voltage and ampere knot is there for our attached on the multimeter to measurement what the value of it. Next, this flow chart show the working principle of our eddy current braking system. When the switch turn on, the disc motor rotate the aluminum disc. When a magnet is placed near the disc without contact, eddy current are induced due to a time-varying magnetic field. This current generates opposing magnetic field according to Lenz's law, producing braking torque and reducing the disc speed. And also before end, we make one for the observation value of the voltage and current to see after we put the magnet, so what the voltage and the current induced from this project.
Hi everyone, my name is Muhammad ALIF BAKAR and my matrix number CE240141, and this is our project for subject electromagnetic field and waves BEJ20303, and our lecturer
Professor MADYA Dr. Yi Si.
And as you can see here, this is our project, and the title of our project is Eddy Current Induction Brake System. And what we have here, first thing first, we have a switch to on off the supply, and then the power supply is battery 3 volt because the DC motor need to have input 3 voltage. And then we have a aluminum disc, and the last one is magnet U clamp. Everyone might be wondering how this project works. Let's take a look and let's go. Okay, this is how the project works. First thing first, as you can see here, we need to switch on the switch. After that, as you can see here, the DC motor is rotate the aluminum disc, and then we grab this thing, magnet U clamp. As you can see here, this is the hole that we need to insert the magnet U clamp. After that, we might be carefully because the air gap is 1 cm. We need to carefully to insert the magnet U clamp to the aluminum disc, and then this is how the project's result. The aluminum disc is slow wind.
Hello, this is our project, the Eddy current induction brake. First, I turn on the switch. The DC motor start to spin the disc, which is covered in aluminum foil. Right now, the disc is spinning very fast because there is nothing to slow it down. Now, I put the magnet near the disc with a 10 mm gap. You can see the disc slow down right away. In theory, the moving foil creates eddy current from chapter 3. This current creates a magnetic drag that fights the motor. Because the motor is fighting this extra load, the current increases and the voltage drops. It is working harder to keep the disc moving. Finally, watch as I pull the magnet away. The disc speed up again immediately. This happens because the eddy current disappears.
For the conclusion, our project successfully demonstrated the practical application of time-varying magnetic field and electromagnetic induction to the development of ND current induction by prototype. The experiment confirmed that when a conductor moves through a magnetic field, the result change in magnetic flux induced ND current. As detected by Lenz's law, this current generates a secondary magnetic field that opposes the initial motion, providing a smooth and effective braking force. The finding illustrates that the braking intensity is directly influenced by the strength and proximity of the magnet, proving that kinetic energy can be efficiently transformed into heat energy without physical contact. By eliminating the friction, noise, and weight excited with traditional mechanical brake, any current system offers a superior alternative for enhancing industrial reliability and safety. Ultimately, this simple model serves a clear validation of Faraday and Lenz's law, showcasing their battle in modern technology such as light speed train, elevator, and roller coaster. That's all from our group. Thank you.